1 you get x is equal to e. Put these boundary conditions, you get e to the power 1 and e to the power 0, which gives you 1 and e, right? But for all the values, all the negative values of y, you are getting x lies between 0 to 1. Okay, this is a fraction. But x is never becoming negative because the value of e is approximately 2.71 to the power something, y. Now the power of a positive number can never become negative. So this will always be positive, right? So this is the conclusion which we draw from here. For x greater than 1, fx is greater than 0. For x lying between 0 to 1, fx is less than 0. Okay, is this clear? Sure. What about x less than 0? In that case, ln x is not defined. Since we have learned that log x is only defined when x is a positive number. Okay, so these are the three different areas where we need to check the values. So if we try to make the graph of this function, वो नहीं रखा. So if we try to make the graph of this function, this definition is important. This is the main thing. So the graph of this function, first of all, since this function is not defined for negative values of x, this portion will be empty. Okay, this portion is empty because x less than 0 is not defined, so there will be no graph over here. Okay, so we don't have to fill out this portion. We just have to care about this positive portion, and it is also breaking up at 1, right? It is also changing its sign at x is equal to 1. From x is equal to 0 to 1, fx is less than 0. So the graph will be negative. For this, it will be positive. So it will go like this. So the graph goes like this. Okay. So for very smaller values, like let's suppose if I take x is equal to e to the power minus 50. Let's check the value for e to the power minus 50. I get ln e to the power minus 50. Now e to the power minus 50 will be a positive number or a negative number? This will be a positive number, like 1 upon 2.7 to the power 50. But this will be very smaller, closer to 0. Okay. So this value will give you minus 50 ln e because of the property. Remember the property? Log a to the power x is equal to x log a. So you get minus 50 ln e. Ln e is equal to 2.7. Ln e will be equal to ln e will be log e to the base e. This is equal to 1. So therefore I get value minus 50. So value is in negative. So you put the values of x over here on the x-axis and you get the values on the y-axis. Similarly, if you put e to the power minus 100, you will get minus 100. Okay, as you start increasing the values approaching towards 1, the value keep increasing and afterward it goes like this. Okay, is this clear? For all the values like e to the power 25, e to the power 50, I will get 25, 50 and so on. So it goes like this. So this is the graph for log x. This is the origin and this is the point x is equal to 1. So for all the values of x greater than 1, this is positive because this is above the x-axis, so the values are positive. For all the values lying between 0 to 1, this is negative. And for all the values negative, all the negative values, this is not defined, right? So just write down the domain and the range of this function. R minus 1. 1 पे 0 हो रहा है ना? The value at 1 is becoming 0. So the function is not defined for negative values as well as at x is equal to 0. At x is equal to 0, this function is not defined. So we can say that x less than equal to 0, this function is not defined. So domain will be all positive real numbers. Okay? Yes? Yes. This graph is changing. Okay. So see, the difference between these two numbers will be very small. Let's suppose this is uh, e to the power minus 50, this is e to the power minus 100, then you have e to the power minus 200. What are the values at this values? Minus 50, then you have minus 100 and minus 200. Okay, so at these three values I am getting these values. So when you plot the points, its slope while decreasing is very high. Okay, even if you try to differentiate this, how do you get the slope of any curve? By differentiating, right? So if we differentiate, f dash x will be equal to 1 upon x, right? So as the value of x decreases, the slope increases. Okay, so for very small values of x, the slope will be very high. So it will be like this. Okay, and as I start increasing the yeah start increasing the value, at here the slope will be almost 45 degrees, because at x is equal to 1, if I substitute the value, it will be equal to 1. So slope will be almost 45. After that it will start decreasing, the slope will start decreasing. Get this? Okay. So in this case, okay, 0 is neither positive nor negative. Okay, so in this r positive, this means 0 to infinity, where 0 is not included, right? So this 0 is not included here. So this is the main trick by which you can plot any graph. First you have to see the values of fx. If you are not getting it, then try to differentiate it and then see it. Okay. So this is the domain, and if we see the range, so also write that slope decreases, yeah, as value of x increases. So this is another thing. So what is the range? What all values are we getting? All real numbers I am getting. See, the domain is judged by the x-axis. What all values of x-axis are there? Can we substitute our feasible values? But the value of range is given by all the values of y-axis, which we are getting as answers, right? So the range will be r here, all real numbers. So domain is r positive, and the range is all real numbers. Now at x is equal to infinity, this slope will become 0. So it starts going like this, and yeah, it tends to become parallel to this x-axis. X-axis. In the beginning, at this point, x is equal to 0, the slope is almost infinity. It will be parallel to the y-axis, right? So it goes like this. Written? Next is exponential function. So these two are related functions. You can also write this down, that log and exponential functions, yeah, are inverse functions. Are inverse of each other, or we can write these are inverse functions. So log function and exponential function are inverse functions. Okay, we'll study this inverse function as well. Now the function, exponential function, is given by this: fx is equal to e to the power x. Do you know the graph of this e to the power x? Can you try? Just try to make this graph. Fx is equal to e to the power x. Mm-hmm. Y-axis will act as yeah. X is equal to Y line will act as a mirror image. नहीं हाँ रेक्टेंगुलर हाइपरबोला एक ही क्वाड्रेंट में होता है पर ये दो क्वाड्रेंट से जाएगा ना e to the power x. So is this function defined for negative values? So this function is defined for any value, right? You can substitute any power of x. There's no restriction. For all the values for x lying between, for x less than 0 specifically, this value of fx will be less than 1. Let's see how. For x is equal to 0, what am I getting? E to the power 0, that is 1. And also for x less than 0, I will get negative values of x. I will get something like this, e to the power minus 5 or e to the power minus 10, which is 1 upon e to the power 5, 1 upon e to the power 10, okay, which are less than 1, but they will be greater than 0, positive. Also for x is equal to 0, fx is equal to 1. For x greater than 0, fx is greater than 1. So the curve goes like this. Okay. हाँ हाँ एक ही बात है. कैसा बना तुम्हारा? बताता हूँ. So mirror image बनाना कभी tricky हो जाता है बहुत. Just try to remember these graphs, ln x and exponential function x. So there's also a term in English called exponential growth. So that means like if a company is growing exponentially, at each moment its growth is increasing. Okay, like at this point the growth is increasing more. So how will you define growth at any point? By the slope. That will be the rate at which a thing is growing. Okay, so you can see that the slope is constantly increasing. Actually the slope of this function is also equal to a to the power x. So at any value, if we want to see the value at any value of x, the value itself and the slope both will be same, right? The value of this function, this one, and the tangent and the slope of the tangent, they both will be same. Okay, so what is the domain of this function? All real numbers. What is the range? R positive. Since the range is defined by the y-axis, only this portion of y-axis is occupied, so therefore range will be R plus. Okay, just make this graph. Huh? क्या इक्वल होगा? हाँ यहाँ पे f dash x की वैल्यू कितनी होगी? e to the power x ही होगी, right? So at this point जो इसकी वैल्यू आएगी, right, after substituting this value of x, the value you are getting for fx, that will be same as the slope. because f dash x gives you the slope of any curve. So at each and every point, the slope will be equal to the value. हाँ वो भी करते हैं इसके बाद. We'll do that. देखो x जब 1 होता है तो इसकी वैल्यू 0 होती है. तो x ग्रेटर देन 1 के लिए एफ एक्स की वैल्यू हमेशा क्या है, ग्रेटर देन 0 है ना. ये मैंने सारी वैल्यूज पुट करके देख ली. दिस आर ग्रेटर देन 1. सो फॉर दिस वैल्यू y इज ग्रेटर देन 0. फॉर x lying between 0 to 1 it is less than 0. Understood? So next is also the exponential function, but instead of e to the power x, let's put fx is equal to or a to the power x in general. So let's see what difference will it make for different values of a. Can anyone explain how for the different values of a, like let's take three values, a is equal to 2, 3, 4. So what will be the changes for 2 to the power x, 3 to the power x, 4 to the power x? Can you draw the graphs? Point पे meet करेंगे. Yes. बाकी just try. Slope. For different values of a like 2, 3 and 4, just try to make this graph. Fx is equal to a to the power x. Hmm. सही है. So if I take 2 to the power x or 3 to the power x or 4 to the power x at x is equal to 0, I will always get 1. 2 to the power 0, 3 to the power 0, 4 to the power 0, they're all equal to 1. So they're all meeting at one common point, which is 1. Now for 2 to the power x, let's say the graph is this one. Now for 3 to the power x, what is the difference between 2 to the power x and 3 to the power x? Now see, for the values which are for the values which are less than 0. Which one is smaller? 3 to the power x is smaller. Like let's suppose some values minus 1. 2 to the power minus 1 is half. And 3 to the power minus 1 is 1 by 3. So for all the values of x less than 0, this one will be greater and this one will be smaller. Okay. But in this case, this is obvious. If we have x greater than 0, greater? Yeah. So 2 to the power 3 will be lesser than 3 to the power 3. So this one will be greater. And this one is smaller. For x less than 0, which one is greater? 2 to the power x. So the graph of 3 to the power x will be like this. And then it goes above. Right? So this will be the graph. Of 3 to the power x, right? So the black pen is 2 to the power x, the blue one is 3 to the power x. And similarly, if you want to make 4 to the power x, its graph will go like this, let's suppose. Okay? So this is 4 to the power x. So the domain and the range will be exactly same as the exponential function e to the power x. And where will be e to the power x in this system? Just between here, just between 2 and 3. Just remember in this case, the order is 2 to the power x is above, 3 to the power x, then 4 to the power x. In this case, it's opposite. Okay? So have you studied the graphs of trigonometric functions in your 11th? All of them? Do you remember? How many of you remember all the graphs? Cot, cosecant, secant, sine, cos, tan? Okay. So let's revise then. Write down trigonometric functions. So we'll start with the 14th graph, which is fx is equal to sine x. So fx is equal to sine x has an upper bound. What is the maximum value of this sine x? 1. So the upper bound will be 1 and the lower bound will be minus 1. So the graph goes like this. So it is a sinusoidal wave. So what are these values? This is pi, this is 0. So all the points where the graph is meeting the x-axis will be n pi. X belongs to n pi, right? So this is 3 pi, 0 pi, minus 2 pi. So this is a graph for fx is equal to sin x. Let's make the graph for fx is equal to cos x on this graph itself. So we have fx is equal to cos x. Is it okay, or should we make it in the other graph? It's okay for the same graph, right? So for fx is equal to cos x, we have to define these points as well. This one is pi by 2, 3 pi by 2. This one is minus pi by 2, minus 3 pi by 2. Okay. So the graph is like this. And at x is equal to pi, now see, there will always be a lag of pi by 2 between the graph of sin x and cos x. The thing which is the sin x graph is doing over here, there's the exact same thing cos x will be doing pi by 2 before. Okay, so see, at 3 pi by 2 it is reaching here, at pi it will be reaching here, right? At 2 pi this is becoming 0, cos x will become 0 at 3 pi by 2, and then here, and then here. Similarly, this graph, right? So one is the graph for sin x, other one is for cos x. So the black one is for sin x, blue one is for cos x. So we discussed these graphs together because the domain and the range of both these functions are exactly same. So domain for sin x will be all real numbers. You can substitute any value of x, right? And the range is always closed interval -1 to 1. For both sin x and cos x, domain and range are exactly same. Please draw the graph of y is equal to sin x. Y plus sin x is equal to sin x. So this is a graph for y is equal to sin x. Okay. So this one,
y plus x sin x.
y is equal to x sin x. Okay, we'll come to that. Understood this thing? So what happens in the case of fx is equal to x sin x? Let's see. So for making the graphs, this is very important to find the critical points and the slope of a curve, okay, for this complicated graphs. So
x मैग्नीट्यूड x हो जाएगा x और माइनस x, क्योंकि साइन के अंदर कोई भी एंगल हो उसकी मैक्सिमम वैल्यू -1 to 1 ही होती है.
हाँ.
आगे x मल्टीप्लाई में वैल्यू x 2 3 जो भी है उस हिसाब से वेरी कर जाएगा.
ठीक है, वो तो ठीक है, बट यहाँ पे x भी तो वेरी कर रहे हैं, आगे आगे बढ़ते रहेंगे, x की वैल्यू भी बढ़ती रहेगी, 10 होती रहेगी, 100 होती रहेगी, इस टाइप से. ठीक है. So just write down the derivative. F dash x will be equal to UV rule plus.
sin x.
Okay. So we have to see the critical points. Are we getting any? We're getting tan x is equal to minus x. So this will be the critical point at where tan x is equal to minus x. I don't think we're getting any help from here. So let's see. Yeah, there's another way. No, let's skip this differentiation part. So see, we know that sin x is 0 at x is equal to 0,
Pi.
x is equal to pi, 2 2 pi, 3 pi, 4 pi, right?
n pi.
Up till n pi. Also, it achieves its maximum value at pi by 2 and
3 pi by 2.
minimum value at 3 pi by 2. 5 pi by 2 again maximum. This is 7 pi by 2. Minimum. Local minimum. So what will happen is the graph will start picking up, and at x is equal to pi by 2
Maximum value.
it will reach its maximum value over here. Let's say this is pi by 2. So the graph goes like this, and then it starts to fall like this. Okay. And then again, for negative values, it will reach minus 3 pi by 2 over here. So it goes like this, and then again falls. Then the maximum value increases more. Then it goes like this, then again falls. Like this. The graph will keep going like this. Are you getting it? देखो pi, 2 pi, 3 pi, 4 pi,
0 n.
इन सब पे तो it has to come down, right? Because it has to become 0. Getting it? So therefore it will keep rising till pi by 2. Maybe it will keep rising a bit more because of the increasing magnitude of x and the less dominance of sin x, because sin x will become lesser than 1 in all these cases, for all these cases, right? For pi by 2 and pi. But at pi it has to become 0. Similarly, for all the values pi to 2 pi, we know that sin theta is negative. So for pi to 2 pi, it will be getting negative values. And similarly, again, it will reach over here, and then after that, it will reach over here, and then, right, are you getting it? Minus 3 pi by 2 से ज़्यादा भी जा सकते हैं वैसे, in fact. Let's see. Because at minus 3 pi by 2, you are getting, this is equal to 1. This is minus 1. At 3 pi by 2, this is becoming minus 1, and this is becoming 3 pi by 2. So it is getting this value minus 3 pi by 2. Peak value, ये भी वैसे कहना मुश्किल है. Let's see. Let's differentiate this. We have to check this. X cos x.
Plus sin x.
So at
Tan x equals -1.
So at x is equal to 3 pi by 2, we are getting f dash x is equal to 3 pi by 2. This is becoming 0, and sine 3 pi by 2 is minus 1. So at all these values, x cos x is becoming 0. At all these peak values, x cos x is becoming 0, but we are only left with sin x, which is becoming plus 1 and minus 1 alternately, right? So yeah, we will not get the peak values, but it will rise a bit more, and then it will fall. So the peak values will be greater than this one, slightly greater. Okay. But since it has to fall, right, at 2 pi, 3 pi, 4 pi, all these values, therefore this has to become 0. We cannot say that this one is a maximum. That is okay. At x is equal to 3 pi by 2, the slope will be 1. At x is equal to minus 3 by 2, the slope will be minus 1. For some values greater, let's check. If we have some value greater than 90 degrees, let's suppose we... Yeah, the peak values are the maximas and minimas, where f dash x is equal to 0. So the graph will go like this, roughly. Okay. So I think the definite graph, for making a definite graph, we have to double differentiate it. Okay. And that is a topic of applications of derivatives, if you know. right? When you study differentiation, then you will study application of derivatives. You will study maxima, minima, tangents, normals. Then we will discuss such things. But roughly, the graph will be like this. Yeah. So the next one is uh, 15th. 16th is fx is equal to tan x. And similarly for negative part. For negative part is simple, just put all this negative, right? Because sine of minus x is equal to minus sine x. So all this will be reversed.
पॉजिटिव हो जाएगा माइनस माइनस
अच्छा हाँ माइनस एक्स साइन एक्स है फिर तो सेम ही आ जाएगा इट विल बी एग्जैक्टली सेम मिरर इमेज पॉजिटिव हो जाएगा गुड सो let's discuss fx is equal to tan x. Just try to make the graph and then make the graph of fx is equal to cot x. Next one. पहले tan x का बनाओ फिर cot x अलग अलग.
तो 5/2 3/2 पे एसिम्प्टोट्स बन जाएंगे
So for fx is equal to tan x pi by 2 this is pi 3 pi by 2. So at pi by 2 the function is not defined. At 0 the function is
0
right. So the graph goes like this and here it goes like this. So these are the lines x is equal to pi by 2, x is equal to 3 pi by 2, minus pi by 2 and minus 3 pi by 2, right? So this pattern will keep repeating itself. Okay. And similarly here. Okay. So at 0, pi, minus pi, 2 pi. For all such values, it is becoming 0. So what is the domain of this function?
r r minus 2n plus 1
Pi by 2. R minus 2n plus 1 pi by 2. So R minus odd integral multiples of
pi by 2
pi by 2, like pi by 2, 3 pi by 2, 5 pi by 2. So what are these? 1, 3, 5. These are odd numbers. So odd integral multiples of pi by 2. So all this will be in the domain, and the range is all real numbers. So you're getting all real numbers on the y-axis. All real numbers are the values corresponding, right? So therefore range is equal to r. Similarly, make the graph for cot x. What is the difference between tan x and cot x? रेसिप्रोकल हो जाएगा तो ये बना लिया. ऐसे ऐसे कैसे कैसे होगा? Cot x is equal to cos x upon sin x. So it will be 0 whenever cos x is equal to 0, and whenever sin x is equal to 0, it becomes not defined. So sin x becomes 0 at
0, pi, 2 pi,
pi
2 pi.
2 pi. Minus 2 pi. Right? So the value of cot x is x is equal to 0 is equal to not defined. At x is equal to 0, this is approaching infinity, positive infinity. So it's over here. And at x is equal to pi by 2, it's coming here. For x is equal to pi, negative. So something like this. Okay? Huh. And similarly, going like this, okay. So this is a graph for fx is equal to cot x. So such graphs which repeat their pattern after certain interval are known as periodic functions. So we'll come to that again. What is the domain? R minus integral multiples of pi. So domain is all real numbers except n pi. Range is R. Next is fx is equal to cosecant x and fx is equal to secant x. नहीं बना क्या अभी तक? बना लिया? एटीन्थ fx is equal to cosecant x. So cosecant x is actually 1 upon sin x, right? So how do we make 1 upon sin x? Okay, so for making 1 upon sin x, first make sin x and then take reciprocal of that. So we have pi by 2, pi, 3 pi by 2, 2 pi, minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi. Okay. So let's first make the graph of
Sin
sin
x.
x here. So the graph for sin x is a sinusoidal wave going like this. Okay. Now the maximum value reached is 1 and the minimum value reached is minus 1, right? Now at x is equal to 0, 1 upon sin x will become, at x is equal to 0, this is 1 upon 0, which is infinity. So it comes from here. The value of cos x, it comes from here. At x is equal to 90 degrees, it becomes 1. So they touch over here. The graph of sin x and cosecant x, they touch over here. And then it again becomes infinity. Okay. So this is the nature for cosecant x between 0 and pi. And this nature technically repeats after every interval of pi. Like see, for x is equal to pi, it is again, if we just move ahead of pi, so the value of sine will be in the third quadrant, the value of x is in third quadrant, it will become negative. So it starts from negative infinity, again touch, and goes like this. Okay. Similarly over here, and similarly here. Got this? So first you made the graph of sin x, and then this is the graph of cosecant x. And then you can erase this graph. Okay. So once you made the graph of cosecant x, then you can get rid of this. And similarly, the same type of peaks and drops you will get in the graph of cos x. So you can get the same thing, the same pattern in cos x. Okay. So just try to make the graph for cos x as well. First write down the domain of this and range of this. What is the domain? So domain are the permissible values, the values which you can put. So we cannot put the values where sin x is becoming 0. So sin x is becoming 0 at n pi.
N pi.
So domain is
R minus n pi.
r minus n pi, and the range is, yeah. So there are two ways of writing the range. Either you can write r minus minus 1 to 1 open bracket, or minus infinity to union, right? So we're getting all these values above 1, below 1, above 1, below 1. So these are the two ways of writing range, r minus minus 1 to 1. So you subtract this interval from all real numbers, or minus infinity to 1 union 1 to infinity. So 19th is fx is equal to secant x. Hmm. हाँ.
और फिर 90 टू और मल्टीपल ऑफ पाई पे वो होगा एसिम्प्टोट्स बन जाएंगे.
Hmm. This is
minus pi by 2 pi by 2 3 pi by 2.
right.
Yes sir.
So these are the values minus 1
1.
and 1, right? So the domain here is all real numbers except odd integral multiples of
R minus 2n plus 1 pi by 2.
2n plus 1 pi by 2, and the range is,
R minus minus 1 to.
yeah, I minus minus 1 to 1. Okay. So next is 20th graph is fx is equal to root x, square root of x. So before moving on to this one, I'll first tell you about inverse functions, so that you know how to take mirror images. Okay. So what are inverse functions? The functions obtained after interchanging the values of x and y, right? After interchanging the values of x and y. So if you replace x-axis with y-axis, you will get the inverse function of the given function. So written, have you made this graph? So the simple examples of inverse functions are, the simplest ones are inverse trigonometric functions. Like you'll study your chapter inverse trigonometry. In that, you will have some functions like this: fx is equal to sine inverse x. And if you have other function, gx is equal to sine x. Now these two are inverse of each other. Let's see how. Fx is equal to sine inverse x. This will be,
Sine inverse
which is technically
sine
x is equal to sine y.
sine y.
And the other function is y is equal to sine x. So they are obtained after interchanging the values of x and y, right? So this one is y is equal to sine inverse x, this one is y is equal to sine x. Other example is, which we studied,
Fx equals cos inverse.
yeah, sine inverse, cos inverse, tan inverse, that's okay. Then we have y is equal to ln x,
E to the
y
power
is equal to e to the power x. So let's first come to the graphs of these two, y is equal to ln x and e to the power x. So the graphs of all such functions which can be obtained by interchanging the values of x and y are actually mirror images along the line y is equal to x or x is equal to y. So the line y is equal to x is this line. So these graphs, you can write that the graph of inverse function, just write it down. The graph of inverse function are symmetric about what?
the line x is equal to y.
Or you can say they are symmetric about origin. Is the graph of sine inverse x? No. Sine inverse x is different from. Uh,
Symmetric about origin.
so I think you're confusing yourself with this sine inverse x and sine x to the power minus 1. Okay. Okay. This one has nothing to do with power. This one is not a power.
Symmetric about origin.
So this one is not a power, but this one is power. So these two are different. Exactly different. So we're making the graphs of ln x and e to the power x. Just make the line. And then if you make the graph like this, right? Now see, for the for the other graph, you have to just remember one thing, that the graph is symmetric about the origin. So if this part is coming in the fourth quadrant, this graph will come in the second quadrant, because here y is negative, x is positive. Here y will be positive, x will be negative, because they are interchanged, right? The values of x and y are interchanged. So the graph will start from here. It is starting from, now here x is tending to 0. I will make some points here. So at this point, x is tending to 0 and y is tending to infinity. Now I just need one point where x is tending to, so y is tending to minus infinity, I'm sorry. Y is tending to minus infinity. I need a point where x is tending to minus infinity and y is tending to 0. So this point will be here. Okay. So we start from here. So this is the point where x is tending minus infinity, y is tending to 0. Okay. This is a point 1, 0. This is a point 0, 1. This one is simple, right? This part ln x is in the first quadrant. This will also be in the first quadrant. Just interchange the values. Now making the mirror images of this part is very easy. Okay. Now this part is a bit tough, that's why I made it. The third quadrant of this portion is missing, ln x. The third quadrant of the graph e to the power x will also be missing, because there is no such point where x and y both are negative. So therefore there will be no such point in the case of e to the power x as well. So these are the graphs. This one is ln x and this one is e to the power x, and they are mirror images about the line y is equal to x or origin. So similarly you can make the graphs of sine inverse x. Actually I don't want to discuss inverse trigonometric function right now, because you have a whole chapter for that. Have you studied in these classes? School. Okay. So the next graph which I want you to make with the help of, by taking some help from this one, is the 20th one which we wrote, fx is equal to root x. Now the inverse function for root x will be fx is equal to x, this is x to the power 1 by 2. So how to make inverse functions? Just put this equal to y is equal to root x, then calculate x in terms of y, and then interchange x and y. Okay, so write down, these are the two procedures of forming an inverse function. Calculate x in terms of y and then interchange x and y. So here x in terms of y will be x is equal to y square. If you interchange x and y, you get y is equal to x square. So the function is y is equal to x square. And similarly, if you have x cube, the inverse function will be cube root of x. Make the graph. Now these two are not inverse functions. Altogether they are domains. For them to be inverse functions, there is one condition. We'll come to that later. Just try to make the graphs with the help of this fact. पहले रफ में बना लो।
ऐसे बनेगा और इसका ऐसे भी।
नहीं, रफ में बना लो पहले। तो मिरर इमेज बनाना कभी कभी ट्रिकी हो जाता है, दैट्स व्हाई आई गिव यू दिस क्वेश्चन। कोई ना कर ले। ये क्या है? ये तो पहला ग्राफ बनाया था हमने। ओके। एक्स स्क्वायर का तो ऐसे बनेगा, रूट एक्स का। बन गया। तो रूट एक्स कैसा होगा? मिरर इमेज बनाना है इस लाइन के अबाउट। हाँ, ये तो ठीक है। ये क्या हो गया, इधर क्यों जा रहा है? ये सेकंड क्वाड्रेंट में है, तो ये किस क्वाड्रेंट में होगा? फोर्थ में। अभी रफ में ही बनाओ, फेयर में मत बनाना। So we know that y is equal to root x and y is equal to x square are inverse of each other. Hence, what we'll do is, we'll first make the graph for x square. It's like this. And then we make the line y equal to x. Where are these lines meeting? Y is equal to x and this curve is meeting y is equal to x square at x is equal to 1. So let's suppose this is the meeting point, x is equal to 1. So we know that 1 comma 1 is a point. So after interchanging the values, 1 comma 1 will again be there. 1 comma 1 is present and 0 comma 0 is also present. So the mirror image, just try to make the mirror images in parts. Okay, the mirror image of this part will be this, and the mirror image of other part, the mirror image of this part will be this, and the mirror image of other part will be this. So this will be the graph. Okay, now see, the only difference between fx is equal to x square and fx is equal to root x is that this function is defined for these negative values. Okay, but we are not getting any negative values from here. Like if you take root 4, you don't get plus minus 2, you just get 2. Okay, if you make the graph of this function like this, will it be a function then? This is not a function. This is a relation. I explained you last time in the yesterday's class, because if we take one value of x, there should not be two values of y, right? In that case, it will be a relation. So therefore, the only part of graph will be this one. So fx is equal to x square and fx is equal to root x are called inverse function if and only if x is greater than equal to 0. So they are inverse function only when x is greater than equal to 0, because x is root x is defined only for this interval, x greater than equal to 0. Got this? Understood? Next is 21st, mod x plus mod y is equal to 1. And the next one is 2 mod x plus 3 mod y is equal to 1. Can you make this graphs? Or you can say mod x plus mod of fx is equal to 1. So this will contain 4 straight lines, right? When you remove modulus, you get plus minus. So we get 4 straight lines. X plus y is equal to 1, minus x plus y is equal to 1, x minus y 1.
X minus x plus y.
Okay. So if we put x is equal to 0 and y is equal to 0 in all these cases, first line will be like this. Second line minus x plus y. So y is equal to 0, x is equal to minus 1. It goes like this, then like this, and like this. So this is the graph. It's a square. Okay. So similarly you can find the area of this. And similarly the next graph will be 2 times mod x plus 3 times mod y. In this case, the value of x will be 1 by 2 and this value will be 0 comma 1 by 3. So what shape are we getting here? No, this one is square. Is this square? Rhombus. This one is rhombus. Because these angles are not 90 degrees. In this case, it was 90 degree. Because this was symmetric, So 45, 45 all angles, but not in this case. Got this? So let's now move on to periodic, oh no, transformation of graphs first. So to discuss transformation of graphs, uh, let's see what kind of transformations will we need. Let's suppose we are getting fx is equal to x minus 3 whole square. Can you make this graph? Yes? Huh? Huh. So in the first type in case of transformation of graph is when we need f of x minus h graph, the graph of x minus h, so write down in f of x minus h we shift the graph h units, no, right words. So if the graph of x square was this, so the graph for x minus 3 square will be this, right? So this was the point 0 comma 0, it shifted to 3 comma 0. x कोऑर्डिनेट में डिफरेंस आ रहा है ना, x कोऑर्डिनेट में डिफरेंस आ रहा है, y कोऑर्डिनेट
जो हमारे पास f के अंदर
हाँ
वैल्यू y है,
हाँ हाँ, तो
y की वैल्यू चेंज हो रही है ना।
y की वैल्यू कैसे चेंज हो रही है? कैसे? हम्म हम्म नहीं, देखो यहाँ हो क्या रहा है, ओनली डिफरेंस बिटवीन एक्स स्क्वायर एंड एक्स माइनस 3 स्क्वायर. अच्छा मुझे ये बताओ, क्या इसकी मिनिमम वैल्यू जीरो है? इसकी मिनिमम वैल्यू जीरो है, क्या इसकी वैल्यू कभी जीरो नहीं होगी?
होगी।
3 पे जीरो हो जाएगी ना, तो तुम तो उसको ऊपर उठा रहे हो, फिर जीरो कैसे होगी? समझ लो. सो द नेचर this graph is showing at x is equal to 0, this graph is showing at x is equal to 3, so that's why we moved it 3 units further, right? Have we done this? Next one is in f of x plus h. Now this is a different one, f of x plus h. What do we do here? In this case we move the graph up, move the graph upwards. Now this h is outside, f of x plus h. Like let's suppose you had this one x minus 3 whole square. Now you want to make the graph of fx is equal to x minus 3 whole square plus 4. So what you will do is, you know that at x is equal to 3 you were getting the value 0. Now you will be getting the value 4. So it goes like this. So this is the value at x is equal to 3. So this is the point 3 comma 4. The graph has been shifted up. So this is the first transformation. This is the second transformation. And let's see all the other transformations in questions, in the form of questions, right? Or that will be better. For example, uh, draw the graphs of following.
सर अगर हमारे पास सिर्फ एफ एक्स प्लस एच होगा तो बस हम उसे बाएं हाथ से भी ऊपर शिफ्ट कर
हाँ
देंगे.
जी. So draw the graphs of following functions. First one is uh, fx is equal to e to the power x plus 3. This is the first one. Next is fx is equal to greatest integer function of 4x, fx is equal to 4 times greatest integer function of x. Next is e to the power x plus 3. Just interchange the orders. E to the power x plus 3 is over here. Okay. So try these 7 graphs. The last two are fractional part of x by 2, and this one is half of fraction part of x. अच्छा ये रेस टू द पावर प्लस 3 वाला ऊपर चला गया।
सर ऊपर नहीं है सर, साइड में शिफ्ट हो गया है, साइड में शिफ्ट हो गया है
कौन सा वाला?
सर, एफ एक्स
हाँ
एवेटेड पावर ई एक्स प्लस 3
ठीक है ठीक है ठीक है, सही है सही है सही है।
-3 -3।
हाँ।
ये जो है ये वाला ये ऊपर शिफ्ट कर दिया है सर,
ठीक है
0
ठीक है
और
ठीक
4
है ठीक
है।
है। ये कहीं बीट भी कर रहे हैं क्या ये वाला और e टू द पावर x
ये कंफर्म है
कर रहे हैं क्या?
सर, वैसे होंगे।
एक बार इक्वल करके देखो दोनों को, मीट करेंगे क्या कहीं? e टू द पावर x इज इक्वल टू e टू द पावर x नहीं करेंगे ना, तो मीट मत करवाओ उनको। ये एक्चुअली
यहाँ से आ जाएगा सर, फिर
हाँ हाँ जी
तो फर्स्ट वाले में अगर हम e की पावर x प्लस 3 है, x को 0 पुट करेंगे तो e की पावर 3 वाला ग्राफ बन जाएगा। सेकंड वाले केस में e की पावर मतलब x को 0 पुट करा तो 4 पे कट करता हो जाएगा।
e की पावर 4 पे e
नहीं 4
4
y
पे हाँ
एक्सिस पे
हाँ
4 पे सर, मूल स्टेप पर कह सकते हो e टू द पावर x प्लस 3।
हाँ
हाँ
कह सकते हैं। क्या कुछ बनाया नहीं तुमने तो? नहीं ये ऐसे नहीं जाता ना।
तो वो ऐसे जाएगा
हाँ
हम इसका 3 स्टेप इधर शिफ्ट करेंगे
हाँ जी हाँ जी
तो
सही।
ये समथिंग इस तरीके से जाएगा।
सही है।
पहले पावर x प्लस 3
और दूसरा
वो कैसे होगा?
इसमें ऊपर चला जाएगा वो ग्राफ 3 यूनिट्स।
3 स्टेप sin x में तो इंटीग्रल वैल्यूज ही होती है, तो ग्रेटेस्ट इंटीजर फंक्शन -1 1 तो ग्राफ वही रहेगा।
मतलब
ग्रेटेस्ट इंटीजर फंक्शन होता है कि वो डेसिमल वाला पार्ट हटाके हमें मतलब हम
सिर्फ
क्लोज
इंटीजर
वाला
पार्ट
करते
देखना
हैं,
है हाँ।
तो अभी इसमें तो कुछ है ही नहीं, जिसमें -1 1 ही देगा वही ग्राफ।
हाँ 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 -1 1 और 0 ही आएंगे वैल्यूज।
तो वही रहेगा ग्राफ, चेंज नहीं होगा।
क्यों? फ्रैक्शनल पार्ट थोड़ी ना है वो, ग्रेटेस्ट।
sin x में तो आते हुए है,
अगर 0.5 कहीं वैल्यू आ रही है
तो वो सिर्फ वो वाले में होता है।
हाँ
हम ऐसे कर सकते हैं जैसे y इक्वल टू e टू द पावर n प्लस 2, तो 2 को इधर शिफ्ट कर देंगे तो y की वैल्यू
नहीं 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 वही तो मैं समझा रहा हूँ। अगर y इज इक्वल टू e टू द पावर x प्लस 2 है तो ऊपर शिफ्ट होगा, अगर e टू द पावर x माइनस 2 होता तब नीचे शिफ्ट होता।
तो सर हम कह सकते हैं y की वैल्यू में ही ये 2 ऊपर शिफ्ट कर देंगे,
हाँ 2 ऊपर
2
शिफ्ट।
कॉमा
हाँ
0।
पर 3 है ना वहाँ पे, मतलब एक ही बात है वैसे तो कोई दिक्कत नहीं है। हाँ 3 यूनिट ऊपर शिफ्ट हो जाएगी, पर ये क्या मीट कर रहे हैं क्या दोनों?
नहीं नहीं
नहीं
करेंगे।
करेंगे।
e टू द पावर x और e टू द पावर 3
पहला हो गया।
यस सर।
सो फर्स्ट वन इज at x is equal to 0 you're getting
e टू द पावर 3
no first I'm making the graph of e to the power x, right? At x is equal to 0 you were getting 1 in case of e to the power x, yeah, so this point is 0 comma 1. So the same thing you will be getting at minus 3 comma 1, right? If you put x is equal to minus 3 you will get e to the power 0 which is equal to 1, so you get minus 3 comma 1 over here. So the same graph will be shifted towards here. So just assume that this is the y-axis and then you make the graph like this. Got this? So the graph shifts towards left side. So if it were x minus 3, then it would have shifted on the other side. And this part is 0 comma e to the power. So don't put your reference at this point. Okay, since you know that if you have x plus 3 your graph is shifting forwards or backwards, that you have to figure out and then take that as reference and then make the graphs. But if you are trying to make these two graphs on the same graph, just make sure that they don't meet because they will not. Okay. No, the graph is So this one is e to the power x and this one is e to the power x plus 3. Or you can just make this transformation. No need to make both the graphs from the same one. So just make sure that you shift this 3 units backward. So that should be a reference point. So have you made this graph? Try the next one. Next one is comparatively easy. Yeah. So in the case of next one, this graph will move 3 units up. So this becomes exactly same curve and this point will be 0, 4. So this is the graph of e to the power x plus 3 and this one was e to the power x. Okay, and this is the graph of e to the power x plus 3. This graph moves upwards, this graph moves backwards. Have you made the third and fourth? Have you started trying? No? Made both of these? Hmm. ये पॉइंट्स क्या हैं? नहीं. We're making the graph of fractional part of x minus 4. This is 4 times fractional part of x. So this rule we haven't studied yet. So just try it by yourself. Will not be less than 3. Please explain. In the second graph, the value of fxn function will not be less than 3. Why not? It can be less than 3. Now, the only difference in the second graph is that, see, at same value of x, you were getting 1. Now at same value of x, you are getting a value which is greater than 3. Greater than the previous function by 3 units, right? So for each and every value of x, you're getting a value which is greater by 3 units. So you just have to move the graph 3 units upwards. That will do it. Okay, so there will be no difference except that the graph will be moving 3 units up. So that's the only difference. So it's not moving down, it's moving up. If you had e to the power x minus 3, then it will move down, right? And it is getting all the values, don't worry. It will get all the values. Will it get negative values also? So it will get the values till 3. X is equal to 3. So why is it getting values at x is equal to 3? Because the minimum value of e to the power x will be 0. So this value will be 0 plus 3. So that will be the minimum value, that will be at minus infinity, right? So the same nature this graph was like e to the power x was going from here to here, right? So you just pick it up 3 units. The same nature will be over here, right? So this is a good way of doing it, and then you erase this line. So these are the two graphs. Have you done the third and fourth? No? Are you trying? Do you need time or should I do it? So this is actually the third transformation. So third transformation is if fx is transformed to k times fx. So this will result in magnification. So the graph will become 4 times bigger. Okay, and if you're getting fx by 2, the graph will become half. So let's try by some examples. For all the values lying between 0 to 1, this value will stay 0, no difference there. Okay, but for all the values lying between 1 to 2, greatest integer function is equal to 1. For all the values like 1.5, 1.9, this value is 1, so fx will be equal to 4. So I'm getting 4 over here. Similarly, the next one is 8. Right?
Yes, sir.
And here, like this,
Minus.
like this. Graph. What is graph? Graph. How does square brackets make case the difference in graph? Okay. Square brackets actually mean these are greatest integer function. So I think they haven't attended the last class in which we discussed the greatest integer function.
सर
Hmm.
जो हमने नेगेटिव वाले में बनाया उनमें वाई एक्सिस वाले पे बनेगा हॉरिजॉन्टल.
हाँ, यहाँ पे y एक्सिस पे बनेगा, यहाँ पे गेन है यहाँ पे. सारे इंटीजर्स पे एक बार हॉलो और एक बार सॉलिड सर्कल बनना है ना. ठीक है, तो ये -4, दिस इज -8, this is 0, this is 8. So this square bracket is actually greatest integer function. It makes all the uh, functions lose their fractional part and they convert them into integral part. Like if we have 1.9, this will be equal to, the box of 1.9 will be equal to 1. If we have 2.3, box will be equal to 2. If we have minus 2.3, box will be equal to -3. So it gives you the greatest integer less than or equal to the given number. So you just have to see the number previous to the integer previous to this number. So just near to this number. Okay. So in case of 4 times fractional part of x, this becomes like this. So if you remember, the graph was going like this, but it has been magnified. Okay. So this will be vertical magnification. Lateral, what do you mean by lateral? Lateral, vertical, horizontal is okay. So this results in vertical magnification. So the graph is not like getting magnified from each and every direction, but this is only getting magnified along the y-axis. Okay. So if the magnification were 4 times everywhere, the graph will be from 0 to 1, 0 to 4 instead of 0 to 1. But the magnification is only this wise along the y-axis. Have you done this fourth one? Are you trying? Just try. What? कौन सा? Third वाला. Okay, third वाला दोबारा बता देता हूँ. तो do you know the graph of this one? Fraction, this greatest integer function x. Now greatest integer function x graph will go like this. This is known as a step function. Okay, why does it go like this? For all the values lying between 0 to 1, the greatest integer will be 0. Like 0.9, 0.5, the greatest integer is 0. For all the values between 1 to 2, the greatest integer is 1. 1.9, 1.2, all values have 1. Minus 0.5, minus 0.8, minus 1. So this goes like steps. Now I am just making it 4 times. So each of these values will become 4 times. So this value is 0. 4 times 0 is 0. 4 times 1 is 4. 4 times 2 is 8. 4 times minus 1 minus 4. एक्स एक्सेस पे वैल्यू सेम रहेंगी क्योंकि उनको हम ऑल्टर नहीं करते, ठीक है। द ओनली डिफरेंस इज along the y-axis, vertical magnification.
सर जो फोर्थ वाला केस है उसमें 0.4 तक जीरो रहेगा अगर एक्स की वैल्यू जब तक 0.4 है।
0.4
सर क्योंकि 0.5 नहीं 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 एक 5 डालेंगे तो
एक
4
बार
आएगा।
बना लो ग्राफ।
तो फिर वो 2 हो जाएगा ना, मतलब अगर हम 0.5 लेंगे एक्स को तो 2 हो जाएगा, तो फिर 2 बाहर आएगी वैल्यू तो बाय 2 हो जाएगा।
हम्म।
तो
तो
ये आप बना दीजिए,
क्या
ये अच्छा नहीं है।
अच्छा नहीं है?
वन से तो वन आएगा, वन से तो टू आया, तो ये एक पॉइंट लॉस हुआ, ऐसे बचा है।
बोलो। नहीं, नहीं किसका? सिक्स सेवन्थ का? नहीं बनेगा ऐसा ही, बनेंगे स्टेप्स ही।
सर कैसे बनेगा? 0.2 अगर हम एक्स ले रहे हैं तब तक हमारे पास जीरो आ रही है वैल्यू,
0.2 तक?
क्योंकि 0.8 हो जाएगा वो जीरो ही रहेगा, फिर अगर हम 0.3 लेंगे तो 1.2 जाएगा वो 1 हो जाएगा।
तो 1 शुरू होना कब से शुरू हो रहा है?
0.3 से
नहीं,
बाय की वैल्यू बनानी तब से शुरू होगी।
तो 0.29 से नहीं हो रही?
सर हम इतना पॉइंट नहीं देख रहे हैं,
बन गया?
2.8 से भी हो रही है फिर तो 1.5
हाँ तो
से।
कहाँ से हो रही है वही तो मैं पूछ रहा हूँ। 0.25 से हो रही है ऑब्वियसली। क्या? वहाँ से भी हो रही है ना, तो उससे पीछे से हो रही होगी।
0.25।
हाँ तो वो तो दिख ही रहा है ना, 4x है, 4x को 1 के इक्वल पुट करोगे, x कितना आया?
0.25।
1/4। नहीं तो देखो ग्रेटेस्ट इंटीजर फंक्शन, the difference arises in the values when this value shift from 0 to 1 and 1 to 2 and 2 to 3 and so on, right? So this value becomes 1 at x is equal to 1/4, then at x is equal to 1/2 it becomes 2, then at 3/4 it becomes 3, then at x is equal to 1 it becomes 4, right? Next one is 4. So 4 here. So this is the value. Okay? So the graph is going like this. So the only difference which is here is that the same nature it was showing for from x is equal to 0 to 1. That is happening for each interval of 1/4, 1/4. Okay? And similarly here also at the intervals of 1/4 it is showing steps.
सर अगर हमारे पास कोई ऐसा मल्टीपल आ गया जिसका बहुत ज़्यादा पॉइंट में आ रहा हो, जैसे ये तो 1/4 है।
हाँ तो तुम ऐसे लिख दो 1/4, 1/9, जैसे 1/9, 2/9, 3/9, 4/9. So these are 1/4, 2/4, 3/4, 4/4, 5/4. So at all these values the nature is changing. हाँ 1 आ रही है ना, तो यहाँ पे पहुँच गई। 1 का ग्रेटेस्ट इंटीजर भी 1 ही होगा। 2/4 पे इसकी वैल्यू कितनी आ रही है? 2, तो यहाँ से जंप करके यहाँ चलेगा 2/4 से जस्ट पहले 0.49 पे, और दिस इज बिकमिंग 1.98, उसका तो 1 ही होता है इस टाइप से। ओके सो अच्छा नहीं लगा, तो फोर्थ इज fx is converted to f of a kx, let's suppose. So what is the opposite of magnification? Antonym? Word.
मैग्नीफाइड इमेज, डिमिनिश्ड इमेज। सर लेंसेज में यही कहते हैं, मैग्नीफाई हो गई इमेज या डिमिनिश हो गई।
Diminish. Diminish. Okay.
सर
Smallification. No.
सर रिड्यूस नहीं।
Squeezed कह सकते हैं.
हाँ
Horizontal. Horizontally squeezed. या हाँ, इसको वर्टिकल स्ट्रेचिंग भी कहते हैं, जैसे पिछले केस में स्ट्रेचिंग हो रही थी वर्टिकली, और यहाँ पे हॉरिजॉन्टली क्या हो रही है, स्क्वीजिंग, या फिर और कोई वर्ड?
सर स्ट्रेचिंग सर।
हाँ ठीक है, तो यहाँ पे पिचक रहा है वो, समझ रहे हो?
सर
हाँ जी।
तो यहाँ पे वैल्यू 4 आई 1 वाले पे, तो मेरा यहाँ पे 3 आ रहा है।
हाँ नहीं,
तो यहाँ से लेके यहाँ तक 0, फिर
हम्म
1, फिर यहाँ पे 2।
तो यहाँ पे 4 ऊपर होगी ना इसके बाद। समझ गए? अगला बना लोगे बॉक्स ऑफ साइन एक्स। सो देखो, तुम्हें साइन एक्स का पहले बनाना, यू हैव टू मेक साइन एक्स ग्राफ फर्स्ट. So this is the graph for sin x. It's a very simple one. If I make the graph for this portion, I can make the graph for each and every portion, right? Because this is symmetric, this is periodic function. It goes like this.
ये तो पहले
For
वाला,
all the values, yes.
तो ये भी वर्टिकली ही स्क्वीज हो रहा है ना।
कौन सा?
इससे पहले वाला जो हमने करा बॉक्स ऑफ 4x।
Vertically squeeze नहीं हो रहा, horizontally. Vertically तो the values remain same, 0, 1, 2, 3, 4. In the third case, the values were becoming
4 8 12।
4, 8. So that was, it was stretching, elongating. So in this case, you have to see the greatest integer function of x. So for all these values from 0 to pi by 2, it will be 0, right? At pi by 2, it will be 1, again 0, till here. So this will be the graph. Because greatest integer function always gives you integers. It cannot give you any other value. So for all the values like from 0 to 90 degrees, like 60 degrees, 70 degrees, 80 degrees, the values are less than 1 and greater than 0. So values lie between 0 and 1. So therefore the greatest integer is equal to 0. At x is equal to pi by 2, the greatest integer will be equal to 1, since the number sin x is becoming 1, and again it will be 0. After that it will become minus 1 till here. This is pi, this is 2 pi. Again goes like this, 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 right? So for any such graphs where you have the greatest integer function, just check that in which interval, in which two intervals of integers your value is lying. Like if it is lying between 2 to 3, like if the graph is going like this, for throughout this region the value will be 2. हाँ 3 pi by 2 पे तो -1 ही होगा. जैसे अगर if I take the value something like this and I'm getting minus 0.2, this can be attained value. So the greatest integer function of minus 0.2 is -1. The greatest interior function of -1 is also -1. So for all these negative values, I am getting -1. Okay. So can you do these two as homework? Right? Or you want me to do? Just tell me. Do you want this as homework or you want it here? कितने लोग बोलते हैं यहाँ करें होमवर्क बाकी ठीक है होमवर्क कर लेना वन था ऊपर है वो वन से ऊपर तो हो ही नहीं रहा
हाँ ये वन वाला पार्ट भी पाई बाई टू से पाई वाला पार्ट
हाँ
एक्स एक्सिस पे ही क्रॉस करेगा उसे वन पे करना चाहिए ना
क्यों वन से ऊपर थोड़ी है वो वैल्यू स्टार्ट्स ड्रॉपिंग
फिर हमने वो डॉट की लगाई ऊपर अच्छा
ऐसा ग्राफ जाता है नहीं 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 यहाँ पे इसकी वैल्यू दिस वैल्यू इज -0.2 उसका जब डब्बा लेंगे तो कितना आ रहा है -1 है ना तो यहाँ पे वैल्यू कितनी है 0.5 और यहाँ पे भी दिस बिकमिंग 0.5 तो फॉर बोथ दीज वैल्यूज this greatest interior function is 0 except the value at x is equal to pi by 2 where this is becoming 1 okay so next write down periodic functions so 6th and 7th are your homework periodic so what do you mean by periodic functions
a function which repeats in a fixed interval of time
time
interval in a fixed
so periodic functions are the functions which satisfy this property f of x plus t is equal to fx where t is the period so write down graphically uh, the pattern of the curve keeps repeating graphically the pattern of the curve keeps repeating after a specific interval or you can say after a specific value and this value is called the period f of x plus t is equal to fx so some very common examples are sin x cos x tan x all trigonometric ratios any other examples you can think of anyone fractional part of x like fractional part of 0.5 is same as the fractional part of 1.5 which is same as the fractional part of 2.5 which is equal to 0.5 the fractional part of all these are same right so in case of sin x we made the graph it went like this right so it was periodic function because this pattern this particular pattern will be repeating itself again and again and again right? So the value which I'm getting here will be the same as the value which I'm getting here. So in the case of sin x and cos x, the period will be 2 pi.
2 pi.
So for sin x and cos x, the period will be 2 pi. Okay, the definition of periodic function was, what was it?
Graph is the pattern of the curve keeps repeating after a specific value, and this value is called a period.
Graphically,
The pattern of a curve
the pattern of curve
keeps repeating
keeps repeating
after a specific value.
after a specific value t, and this is called.
Period.
So this will be the mathematical definition. This is very important. F of x plus t is equal to fx. So when x plus t is equal to fx, then t is a period and this function is periodic. So sin x and cos x both will have a period of 2 pi. What about tan x? It will have a period of
Pi.
pi. So tan x goes like this and this. So this interval of pi is repeating itself after each pi, right? So tan x, similarly cot x have period of pi. What about secant x and cosecant x? They will have the same thing. So sin x, cos x, secant x, cosecant x, they all have a period of 2 pi. So you just have to see the graph. If it repeats itself after a certain time or a certain value of x, then that value of x is called the period and the graph is called periodic graph or periodic function. Then you have the third one, fx is equal to fractional part of x. So if you remember, last time we made the graph like this. Remember? We made this graph for fractional part of x. Now this pattern, this particular pattern is repeating itself, right? After each interval of what? So what is the interval? 1. So therefore the period will be equal to
1.
1 here. Okay, is this clear? So the difficult type of questions which you can get in the case of periodic function is that you can get a combination of two functions, like let's suppose you have you made this, right? Tan x cot x, just make this one. So question can be like this, like what is the period of sine of 3x? Can you tell me? What is the period of sine of 3x? 2 pi. 2 pi by 3. So what happens, just see the fourth transformation which we wrote. When you have f of kx, right, we did two things. First one was k of fx and then we had f of kx. So the graph gets squeezed. Yeah. So the graph will be, if we had 2 pi, then I will get 2 pi by 3 over here, right? The same nature it will play at 2 pi by 3. So the graph will go like this. Let's say this is pi by 3, 2 pi by 3 and pi. So the graph is like this. Okay. And this will be the period. Are you getting it? From 0 to 2 pi by 3, it is completing its cycle because it is sine of 3x. So to make just simple thing, to make this 2 pi, because the interval of sine x is 2 pi, therefore 3x is equal to 2 pi. What is the value of x? This is equal to 2 pi by 3. So therefore the period here will be equal to 2 pi by 3. Okay. Or you can remember this as a formula that period, write this down as a note, period of sine of kx is 2 pi by k. The period of sine of kx will be equal to 2 pi by k. Like if I had sine of 7x, the period would be 2 pi by 7. Because the graph is getting squeezed. It's getting
फिर अगर हमारे पास 3 sin x होता तो कोई फर्क नहीं पड़ता
3 sin x पे कोई फर्क नहीं पड़ेगा.
उसमें सिर्फ मैग्नीट्यूड चेंज होता है
Exactly. Good. So similarly write down this question as well. If we have 3 sin x, what will be the period? So in the case of 3 sin x, there will only be vertical magnification. So the graph will be like this. But these points will not change. This will be 2 pi. This will be 4 pi. The points on the x-axis determine this period, not the points on the y-axis. So the period is 2 pi again. Okay. Next is, if you have, so write down the period is same, is equal to 2 pi. What if you have third question, sine of x by 5? What is the period of sine of x by 5? 10 pi. So the period will be 2 pi upon 1 by 5, which is equal to 10 pi. So simply the period will be equal to 2 pi by k. And similarly, if you have tan of 5x, now the period of tan x is equal to t is equal to pi, right? So for tan x the period is equal to pi. So for tan of 5x the period will be equal to pi by 5. And the tricky part is when you get two such things, like if you have sine 2x, or no, sine x by 2 plus cos x by 3. What is the period of this? Sine x by 2 and cos x by 3. Individually you can find for both.
5 + 6 10
नहीं, जिसका बड़ा होगा वो लेंगे. जहाँ दोनों So period, okay, see, the period of sine x, I can also say that the period is 4 pi. There's nothing wrong in that. Sin x का पीरियड मैं ऐसा भी बोल सकता हूँ कि मैं ये दो पीक्स देख रहा हूँ और ये दो पीक्स रिपीट हो रही हैं बार बार, राइट? बट when I define period t, this is the smallest such period after which they are repeating. This is smallest such value after which the pattern is repeating itself. Here I can also say that the period is 6 pi or 8 pi or 10 pi. But finally, I get to know that the smallest period after which this pattern is repeating is 2 pi. So in this case also you have to check the smallest period. So in this case, the period is obviously 4 pi. In this case it's 6 pi. So it will be 24 pi. So you have done such questions. If a person moves 4 steps and the other person moves 6 steps, when can they meet? What will be the same point from which they both pass? You will take? Huh? Like the period of sin x by 2 is 4 pi, cos x by 3 individually is 6 pi. But I want to find the period of sin x by 2 plus cos x by 3. What will be that? 12 pi. Why? LCM ले ले. Good. So it will be the LCM of these two. Finally, you don't get it? Okay, I'll explain. So instead of adding these two functions, I will just make these two functions on the same graph, and then you can easily decide. So LCM, yeah, right. So first is sin x by 2. Okay, this one will be a tough graph. So you have sin x by 2 plus cos x by 3. Period here is 4 pi, here is 6 pi. Okay. So you get 2 pi, 4 pi, no. 2 pi, 4 pi, 6 pi, so the period for this sin x will be 4 pi. Right? What is this? Sin x to the power? Sin x to the power half, the period will be same. The period will be same as sin x. Okay. When you do power, it makes no difference, because you're not altering the values of x or y. So that's why there will be no difference. But if you're making this x by 2, or this is x by 3, or this is root x, then it might make difference. So yeah, what will be the graph of cos x by 3? We'll start from here. No. So where it is, this is giving 3 pi and pi by 2, 3 pi by 2. So 3 pi by 2 is here. So we'll get such graph, and I get here 6 pi पे क्या होगा? हाँ, दोबारा यहाँ पे. हाँ, तो this will be the graph. Right? Similarly, 12 pi पे फिर से complete हो जाएगा. Like this. मैं कट करने से क्या लेना देना हमें? We're just seeing. We just want to see that where this pattern is completing itself. Now see, this was the point where both of these were at these positions, right? And this is a point where both of them are in the exact same position, right? This is the graph for sin x, and this one is for cos x. So they are at exact same position right now. So this is what I wanted to tell, that if this is moving like 4 steps and this is moving steps, so when will be the line where they meet or where they cross each other, something like that. So that will be after the LCM of these two. Okay. So at this point, they will start the journey again, and they will form the exact same curve. Okay, since they are starting from these 2 points. So whenever you have a period 1, the first thing has period 1, the second has period 2 and 3. Then the final will be LCM of P1, P2, P3. Okay, just keep this in mind. So the next question asked was sin x to the power half. So that will be 5th question. So sin x to the power half, just write down that the period will be same. period is equal to 2 pi. Next is fx is equal to mod of sin x. What will be the period of fx is equal to mod of sin x? Anyone? Yeah, pi. And what will be the period of mod of sin x plus mod of cos x? So this one you have to try at home. I'll tell you the answer for this one. This is pi by 2. The period of pi by 2. Just try to do this one. Fx is equal to mod sin x. So what do we mean by modulus of sin x? So modulus of anything makes the negative things positive, right? So if I take a negative thing, like the graph will go like this for sin x, and again like this, and again like this, right? So you have to make this negative thing positive. So the graph will be like this. So I will get all the similar peaks. This negative part will be shifted to positive part. So if you have to take modulus of any function, so this will be the transformation number 5. So transformation number 5 is, if you are taking modulus of fx, you shift the graph above the x-axis. So the graph which is below the x-axis, you take the mirror image of that graph and you shift it up above the x-axis. Take the mirror image of negative part. So this will be the final graph, going like this. So what is the period? So this is the time interval, this is the value of x after which it is repeating itself, and this part is pi. So the period here will be equal to pi. Okay. So next this one is homework. Next topic is odd and even function. We have time. Let's start with the topic. Write down odd and even function. Now, so what are odd and even functions? Symmetric about? That will be odd function. So even function will be a function where f of minus x is equal to f of x. So that makes no difference in case of even functions. For example, cos x. Okay. Any other example? Yeah, secant x, mod x, x square, x to the power 2n, all the even powers of x, right? No. Root of minus 3 will be root 3 iota. No? And in all these cases, if you put cos of minus x, that will come out eventually into cos x. So mod of minus x will convert into mod of x. X square is same as minus of x square. And in the case of odd functions, f of minus x is equal to minus of fx. Like if you have sin x, tan x, cosecant x, and something like that, or you have x cube, right? Or you have signum function of x, or you have x to the power 2n plus 1. So for all these values, f of minus x will be equal to minus of fx. Understood these two things? And then there are the third types, which are neither odd nor even. Okay. neither odd nor even. So how do we check whether a function is odd or even? Just put the value minus x in that function, okay, and then you'll get an answer. So try this question fast. Root x square plus 1 plus x. So tell me whether this is an odd function or an even function. So to check whether the function is odd or even, you put the value of f of minus x. If you're getting negative of that function, that will be odd. If you're getting positive of that function, it will be even. Neither. ln log. आई कहाँ दिख गया तुझे? लॉग है उसके आगे. हाँ. So इसमें you'll have to use some properties of logarithms, like if you take f of minus x, this is equal to ln root x square plus 1 minus x, right? But you want to make it something like this so that you can judge whether this is odd function or even function. So I can anti-rationalize, or you can say rationalize the numerator. We can do that thing. So I can multiply this by this factor so that it becomes root x square plus 1 minus x multiplied by root x square plus 1 plus x upon root x square plus 1 plus x. Understood what we did? Okay, so we rationalize the numerator, and then we get, what do we get in the numerator? X square plus 1 minus x square upon
under root x square plus 1 minus plus x.
Right? So I get ln 1 upon,
Under root x square plus 1 plus x.
what can I say about this? Odd function, how? So I can write that this is equal to ln root x square plus 1, sorry, plus 1 plus x to the power minus 1. This is equal to minus 1 times ln root x square plus 1 plus x. So this is an odd function because f of minus x will be equal to minus fx. Alright? Clear? So rest of the things we'll discuss in the next class.